Welcome to myprojectbazaar.com.
Now we discuss about the artificial neural network based locking scheme for active filter. In our proposed, the base locking control scheme based on artificial neural network for active power filter. It is estimating the fundamental frequency for control the base locking. It given the better result compared to the existing method. The ANN is the good algorithm to determine the base information for the base locking. The base information and the frequency estimation are utilized to generate the base locking signal. This paper presents a base locking control scheme based on the artificial neural network for active power filter. Base locking is achieved by estimating the fundamental supply frequency and generating a base locking signal. The non-linear least square base approach is modified to estimate the supply frequency to improve the accuracy of the frequency estimation when the supply voltage contains harmonics that are not known yet. Pre-filtering stage is introduced. In stunt ABS application, the information of frequency is sufficient, but also the base information of the supply voltage is required to generate a unit template that is the base locked to the supply voltage. Therefore, an adaptive linear neural base scheme is to extract the base information of the supply voltage. The estimation system frequency and base information are the utilized to generate the base locking signal that achieves a perfect synchronization with the fundamental supply voltage. It is the flow diagram for our proposed work. In this flow diagram, the 3-phase current will be sent to the load and we get the signals from before the load and it will be go to the ANN controller. The ANN is the artificial neural network. It is the one of the neural network for classify the features for identify whether it is the normal or abnormal. In our process, we check the fundamental frequency of the output current from the load. If the fundamental frequency will be changed over desired level, then artificial neural network send one signal to the APF. The APF is the stunt controller and it will be generate the 3-base voltage level by using the capacitor. The capacitor will be charging and discharging level based on the input. Now the fundamental frequency will be reduced at a particular level, then the artificial neural network automatically control the stunt APF. The stunt APF give the additional current or voltage into the primary circuit by using the some filter, and that filter will be reduce the harmonic of the stunt generating current and it will be connected to the grid. Then the load will be get the current frequency for control the load. Then artificial neural network will get that current value from that load. Then it will be change the another signal for the fundamental frequency corrected in the stunt APF. Then stunt APF will be stop for sending the current for the main circuit. So the fundamental frequency will be maintaining in that circuit. For that reason, the output will be getting the low harmonic and best accurate result. Now we go to demo of our process. In our process, we use several blocks like 3-base source and the RL filter and the voltage and current measurement port, and different loads will be connected and the scope will be used for identify the output voltage, and the stunt ABF will be used based on the controller and the artificial neural network circuit, and then use the breaker for connect the stunt ABS output from the main circuit. In the main circuit, the 3-base source and RL and the VA measurement and load will be connected into seriously. Now the 3-base source is acting as a source of grid. The 3-base source generates a 430 volt and 50 Hz frequency at 0 base angle. The 3-base AC source will be through the RL filter. The resistance will be reduce some amount of current from the AC source, and also the filter will be reduce the harmonics of AC source. Now that source will be go to the VA measurement port. The VA measurement, it measures the voltage and current for current input. That voltage and current will be used to control the shunt ABS. Then it will be directly connected to the load. In the load side, there are two types of load will be connected. One will be the DC load and another will be the 3-base AC load. The DC load will be connected through the inverter. The inverter gets the 6 diodes for convert the AC input to DC input. And that inverter will be connected to the RL filter with breaker. The breaker will be chosen where the load will be connected to the main circuit. And then the RL filter reduces the harmonic for AC source. And that voltage and current of will be measured from the 3-base voltage source and also the single base DC source. Now that measured voltage will be go to the scope. Now that measured voltage will be sent into the shunt ABF. In the shunt ABF, the two capacitor will be used. The two capacitor will be acting as a charging and discharging purpose for shunt. And then the DC output will be, because the capacitor will be generate the DC output. The DC output will interconnected to the rectifier, and then rectifier will be generate the 12 pulse based on the PI controller and also the artificial neural network. And that after the rectifier, the DC current will be converted to the AC voltage. That AC voltage will be goes to the filter, L filter, and then it is interconnected to the main circuit. And then the output of the voltage and the current will be go to the PI controller and the artificial neural network. The artificial neural network will be find the fundamental frequency of current output and the voltage, and that will be generate one signal and it is sent through the PI controller. The PI controller and control the pulses for generating. That generated pulse controlled through the inverter, so that the DC capacitor voltage will be controlled based on the artificial neural network and the PI controller with output of the 3-base AC from shunt. And then the shunt will be connected to the through the breaker with the main circuit. If the main circuit will not be generate the particular amount of frequency, then the shunt ABF automatically connected to through the breaker for connect the main circuit. Then the main circuit built up the fundamental frequency, attend the fundamental frequency, and then the shunt ABF will be stop that generating current for through the main circuit. So that reason the fundamental frequency of the output will be maintained. Now the output will be shows the supply voltage. The supply voltage will be the 430 volt, and the inverter voltage, it is a 3-base AC voltage and it is 200 volt amplitude. And the DC voltage will be maintained at the 1000 voltage level. And the load voltage will be the 230. And the load current will be the 50 amps. And both will be the 3-base. And the supply current will be the 10 amps. And it is 3-base current. And the load current will be the 0.2 amps. And all of it is 3-base. And the DC voltage will be the DC voltage will be measured in the shunt ABF. Now in our process source, our output harmonic will be reduced by using the artificial neural network and shunt ABF. It is used to reduce the harmonic level in 3-base grid for maintain the power of the grid. Thank you.